In this lesson, we're going to talk about how to solve systems using substitution. By the end, you should be able to solve a systems of equation using substitution when both equations are in slope-intercept form. Substitution, this is when two things are equal. They can be freely swapped out or substituted for one another. A prime example of this is a substitute teacher takes the place of the classroom teacher when they're out. And so they've swapped in. We use substitution for a variety of different reasons, but one of those reasons is substitution is a way to get an exact answer, where graphing is not always conducive. So graphing is good when we want to estimate the answer, but when we want exact answers, graphing is not always the appropriate method. And so we use methods such as substitution in order to get that. Depending on how the equations are set up, substitution can sometimes be faster and easier than some of the other methods that we have. Our steps for substitution when both equations are in slope-intercept form is to set the two equations equal to one another and then solve it for a multi-step equation. Again, when two things are equal to the same thing, then that means that they're also equal to each other. Once we solve it, you're going to plug in the answer that you have into one of the two original equations to get out the second coordinate for your ordered pair. It's important to remember, though, that our solution for any systems of equations is an ordered pair. So once we get out one of the values, we need to plug it back in to get the second value. Let's look at the following example. So here we have the equations y equals 3x minus 8 and y equals 4 minus x. Now, both of these are y equals, so both of these are in slope-intercept form. Because 3x minus 8 is equal to y and 4 minus x is equal to y, what this tells me is that they are also equal to each other. And so I can set up a third equation, which would be 3x minus 8 is equal to 4 minus x. Now, what this is helpful for is it allows me to solve the equation now for x, whereas before we could not. So I'm going to solve for x, so we start by getting x's on the same side. So this would be 4x minus 8 equals 4. Add 8 to both sides, so 4x equals 12. Divide by 4, that means x is equal to 3. So now I know what x is. Now that I know what x is, I can go and I can find the y. So I take x and I put it into one of the two original equations. So I'm going to put it in the second one, just because that one looks a little bit easier. So I have y equals 4 minus x, or 4 minus 3, so y is equal to 1. So my solution is 3, 1. Now what I want to do is I want to go back and I want to check it in both of my original equations. So x was 3, y was 1. So I start with my first one. 3 times 3 is 9, and 9 minus 8 is 1. So I know this one's correct. Again, y was 1, x was 3, 4 minus 3 is 1, and so we're good on that one. So I know that my solution is 4, 1. Again, we have a similar problem. Y equals 3x and y equals negative x plus 8. Because 3x is equal to y and negative x plus 8 is equal to y, that means that they equal each other. So I can set up a secondary equation, or a third equation, where 3x is equal to negative x plus 8. Again, if I add x to both sides, I'm solving this for x now. 4x equals 8. That means x is going to be equal to 2. So I have my x value. Again, I need to take it and I need to put it into one of the two original equations. I'm going to put it into the first one. Again, just because this one looks easier to solve. So this is 3, y equals 3 times 2. So y is equal to 6. Again, so I know that my point is 2, 6. I want to check my solution. So remember, 2 goes in for x, 6 goes in for y, and for both, 3 times 2 is 6, so that first equation is correct. Negative 2 plus 8 is also 6, so I know my second equation. So I know it works in the second equation, so I know both equations work with this given solution, so I know my solution is 2, 6. I have a third equation, so similar again, y is equal to x minus 7, y is equal to negative 2x plus 8. Again, because both of these expressions are equal to y, that means that they're equal to each other. So I can set up an equation with those two. So x minus 7 equals negative 2x plus 8, and we're going to solve it. So this is 3x minus 7 equals 8. Plus 7, this is 3x equals 15. That means x is equal to 5. I know that x is equal to 5, so if I take this and put it into either equation, I'm going to put it into the first one, again, just because it looks a little bit easier. So instead of x minus 7, I'll have 5 minus 7, which is negative 2. So my x was 5, my y was negative 2. Again, I want to check this in both. So negative 2 is equal to 5 minus 7. That's true. Negative 2 is equal to negative 2 times 5 plus 8. So that'd be negative 10 plus 8. And that does equal negative 2. So I know this. So I know it works in that equation. So because this point works in both equations, that is the solution to the systems. When we're looking at word problems, we need to make sure that we can also write the equation. So Sarah narrowed down her cell phone choices to 2 companies, Verizon and Sprint. So Verizon charges a $40 line charge plus $15 per gig of data. So I know my first equation here is going to be y equals 15x plus 40. We know Sprint charges $100 and has unlimited data. So the cost for Sprint is just $100. My 2 variables here are x is equal to number of gigs of data, since they charge $15 per gig, and y would be the total cost. Again, both of these are equal to y, so both are in slope-intercept form, which means that they also equal each other. So 15x plus 40 will be equal to 100. I can solve this for x. So 15x is equal to 60. That means x is equal to 4. We already know y. Y was equal to 100. So I know that my ordered pair is for 100. But that doesn't really help me in this problem, because it's a real-world problem. I need to write this out in words. So at 4 gigs of data, both companies charge $100. So at 4 gigs, the companies cost the same at $400. Again, if we're writing it from a table, again we have this table that has 2 y values, so x, y, and y. We're going to write the 2 equations from the table, so let's start by finding the change in y over change in x. So my change in y for my first table, as I go from 65 to 155, is increasing by 90. My change in x is 2, so 90 over 2 would be 45. So it's 45x. I need to go back to get the y-intercept, so if I go back 1, that means I need to go back 45. Half of 2 is 1, half of 90 is 45. 45 minus 60 is, or 65 minus 45 is 20. So my y-intercept for this first equation is plus 20. So y equals 45x plus 20. To get my second equation, again, change in x is still 2. Change in y this time, though, is 70. To get from 95 to 65, that's plus 70. So change in y is 70 over change in x, which is 2. That would be 35 when we simplify that, so 35x. Again, if I go back 1 to get to 0, I've got to go back 35. So 95 minus 35 would be 60. So that's plus 60. So there's my two equations. My two variables here, x is time, so x is number of hours. Y would be total cost. Since both of these are in slope-intercept form, I can set them equal to each other. So this would be 45x plus 20 is equal to 35x plus 60. If I subtract 35x on both sides, this would be 10x plus 20 equals 60. Minus 20 on both sides, this would be 10x equals 40. So x is equal to 4. Again, I take one of my two equations, and I plug it in. So to get the y. So let's take the first equation. So let's take y equals 45x plus 20. Y equals 45 times 4, because that was my x, plus 20. 45 times 4 would be 180, plus 20. 180 plus 20 is equal to 200. Again, we've identified the solution, which is 420. 4 and 200, not 420. 4 and 200. What this says is at 4 hours, both companies charge $200. All right, our last one is to look at the graphs. So writing the two equations from the graphs. So for my blue line, I need the slope, which happens to be 2 over 3. X. My y-intercept for this is plus 2. For my red line, we get y equals going up 2 over 1, so 2x. And my y-intercept there is minus 6, or negative 6. Solving this using substitution, we have 2/3 x plus 2 is equal to 2x minus 6. I don't want to deal with the fraction here, so I'm going to get rid of it. Remember, to get rid of fractions, you multiply everything by the common denominator. Since there's only one, I would multiply everything by 3. The 3 here would cancel out, so that's 2x plus 6 equals 6x minus 18. Multiply everything by 3. And then I can begin to solve this. So if I subtract 2x on both sides, this would give me 6 is equal to 4x minus 18. Add 18 on both sides. This would give me 24 equals 4x. So that means x is equal to 6. Take one of my two equations. So if I take the first one, 2 times 6 is 12. 12 minus 6 is 6. So y is also equal to 6. So my solution for this one would be 6, 6. Before watching the next video, consider the following statement, which is, what is the first step in the substitution method?